Hey everybody. So last class we talked about u-substitution and there were a few examples we didn't get to, and so that's what we're going to work on today. Um, but basically most of the time when you're using a u-substitution, the hint for using it is that the derivative of part of the thing you're integrating is another part of the thing you're integrating. Okay, so again, most of the time, okay? So you can use a u-sub if the derivative of part, just part, okay, of the thing you're integrating, of the function you're integrating, is another part of the function you're integrating. Okay, so one more time. You're going to be integrating something if the derivative of part of it is another part of it. That's most of the time when you use a u substitution. There are other times as well, which that's what we're talking about in this video. So the ones where the derivative of part of the thing you're integrating is another part, that's what we worked on in class. And then what I said was this other part has to be multiplied by the rest of the function that you're integrating. So there has to be some kind of multiplication going on. Okay, so for this part, it's got to be multiplied by the rest of the function. And I also said that if the derivative of this part, which is therefore this part, doesn't, if this derivative has a number in front of it, but this other part has a different number in front of it, that's okay. So I'm going to write down that the number in front doesn't matter. Okay, so we'll work on a lot of examples of this kind of problem. Again, we did a lot in class, but make sure you do a lot more homework problems on it. Get real good at it. What this video is about is the other times that you can use u-substitution. There's only really a couple other times you'll ever use it. In general, though, you're going to learn a lot of integration techniques. And how do you know which one to use? The answer is use the one that works. I'm just going to show you a couple other times where u-substitution works. So let's go through that. Other times that u-substitution works. In this video, we're going to do two different kinds of problems. We're going to do one where like they're simpler than the ones we've been doing. But because they're simpler, you might not notice that they're u-substitution problems. So we're going to work on some simpler problems, and then we're going to work on some problems that are a little bit harder than the ones we did in class. So this first example is, it says sometimes you're just going to make u a part of the thing you're integrating just so that the new integral you get is simpler than the old one. You always want the new integral, this should say new integral, the new integral needs to be simpler than the original one so that you can integrate it. Because if you could have integrated it at the beginning, what do you need to do u-substitution for? You want to turn it into a different integral that's simpler. Okay, so it says here you want to make u part of the thing whose derivative is just a number. So if you see some big part, some big piece of the thing you're integrating whose derivative is just a number, you might try that as your u. So it says sometimes you're going to make u part of the thing you're integrating whose derivative is just the number. So what I'm saying is, if you see like, a 2x plus 5, for example, the derivative of that is just 2. So maybe you make that u and see what happens. But don't ever make u equal to x. I mentioned that in class today. Don't ever make u equal x because that will do nothing for you. All it will do is change all the letters in your problem from x's to u's. You'll end up with the same exact integral, just different letters. So you want to end up with a simpler integral. So don't ever make u equal x. But making u x plus 1 might be very helpful, or u equal 2x, depending on what the problem looks like. Okay. So take a look at this one real quick. And guess what u is going to be? I mean, as it is, I don't know how to integrate this right now. But you might say, okay, let's make u... Well, if we make u just whatever's inside the root here, what's the derivative of that? Okay, so if you make u equal 3x minus 7, then the derivative of u is just 3. Of course, you have to put a dx. And then what will end up happening, we're not going to do the whole problem right now, but you'll end up getting square root of u. And, some stuff over here. But square root of u is much easier to integrate than square root of this whole mess. So that's the idea there. So in this problem, if I was going to have you do it, you would make u just the inside of the root, the entire inside. Notice the derivative is just 3. Because see, when you do u substitution, you need the derivative to be somewhere else. But in this case, if you make u equal this, the derivative, I would need it somewhere else, but there is nothing else really. But if you take the derivative as just a number, then it's okay, because number in the front, we never care what the number is. Okay, so one more time. If you make u some big mess whose derivative is just a number, that might be something to try. You don't need the derivative to be somewhere else because the derivative is just a number, and the number you don't care about. So for this one, u is going to be 3x minus 7. Let's look at another example. So I want you to guess what u would be here. We're not going to do the problem yet, but let's just guess what u is going to be. So again, don't make u x. If you made u 9x, okay, that's not horrible. If you made it negative 9x, that's still pretty good. If you made it the whole entire thing, well, which one's better? Well, if you make it 9x or negative 9x or 4 minus 9x, they all have basically the same derivative, 9 or negative 9. So the better thing to do is make it as big as possible, because if you make u have as much stuff in it as possible, then your new integral is going to be a lot simpler. So that's the idea. So for this one, we're going to make u equal 4 minus 9x. And the derivative is negative 9, the derivative is a number, so I don't need the derivative to be somewhere else because it's just a number. We can deal with the number. Okay, so let's do a couple of examples like this. Okay, so let's actually do this integral now. Okay, so for this one, again, the idea is you want u to swallow up as much of the function as possible. As long as the derivative of u is a number, it's going to be fine. So what are we going to make u? We're going to make u the inside of the root. So we start off by writing let u equal 3x minus 7. And then you're going to find du. So what you do is you just take the derivative of 3x minus 7, which is 3. And then don't forget you got to put a dx on this side. And then you should solve that for dx. So let me just go ahead and write that over here. So you get dx equals du over 3. Okay, now we can do the problem. So now that we know what u is, the idea is you want to change the integral from x's to u's. So I want my integral to have only u's in it, nothing else. And then I also want my new integral to be something I know how to integrate. Okay, so let's go ahead and do this. So now, it's instead of square root of 3x minus 7, it's square root of u, because u is 3x minus 7. So square root of u. And then instead of the dx, what are you going to put here? You're going to put d over 3 instead of dx. So du over 3. So the good news is that my new integral now only has u's in it. And it's simpler, and it's something that I'm going to be able to integrate. So let me just rewrite it a little bit here. So this is the same thing as 1/3 u to the 1/2. I haven't integrated yet. I'm just rewriting the function in a way that's going to be easier to integrate. When it's a root and you're trying to integrate, it's usually harder, but if you write it as a power, we have a power rule for it. So now we can integrate this. So we went from x world to u world. So we just changed our integral from an x integral to u integral. Now we'll actually do the integrals. We'll find the antiderivative of this. So we got 1/3. And then when you integrate u to the 1/2, you have to add 1 to the power. When you add 1 to 1/2, you get 3/2. You can get 3/2 over 3/2. Now this is an indefinite integral because there's no numbers over here on the integral sign. There's nothing there. So that means you have to put a plus c at the end. In other words, I'm asking you to find all the antiderivatives. So you put plus c. So that's our answer. But the original integral had x's in it, so you want your final answer to have x's in it. So we started with an x integral. We change it to a u integral. We do the u integral. And once we have our answer, put back in what x is, what u equals. So change u to x. This is how you're going to do that. It says u equal 3x minus 7. So every u you see in the answer, you're going to change it to 3x minus 7 so that our answer will only have x's in it. All right, a little bit of cleanup here. So if you were to flip this, you get 2/3 and multiply it by that, you're going to get 2/9. So 2/9 u to the 3/2 plus c. And then the last step, change the u here to 3x minus 7, and you get 2 over 9, 3x minus 7 to the 3 halves plus c. And that is the answer to that one. Since this problem doesn't have numbers on the integral sign, that's the end of the story there. When it does have numbers on the integral sign, there's two ways to do it, but this one doesn't have numbers, so it's just asking to find all the antiderivatives of that function, and that's the answer there. You can also check it, which I'm not going to do right here. You can check it by taking the derivative and see if you get the function of the integral. So if you took the derivative of this, you want to check and see that you get that, and indeed you do. Go ahead and check it. All right, let's go do another example. Okay, so this one's a little bit different because now it has numbers on the integral sign. So that means there's two ways of doing it. So I'm going to go ahead and do it both ways. So let's start off by writing what u is. So we're going to let u equal, again, you look around, think what u would be, and you come up with 4 minus 9x. And the reason I'm choosing that is because the derivative is a number. So in other words, I don't have to have the derivative somewhere else because the derivative is just a number. And I want it to have all that stuff. Instead of just 9x or negative 9x, I'd like it to be as big as I can make it and the derivative still be a number so that my new integral becomes much simpler. Okay, so that's my u. Then you find the derivative of u. So derivative is, if you take the derivative, you get negative 9 and then a dx here. Don't forget the dx. And then again, you have to solve this for dx. If we solve it for dx, you get du over negative 9. Okay, so there's my u stuff. And now let's call this solution 1. Okay, so solution 1. So for this method of doing the problem, I am going to, so I'm starting with x's. I'm going to go to u world. I'm going to go back to x world, and then I'm going to plug in my numbers. So we're going from x to u, back to x, and then numbers get plugged in afterwards. Okay, so that's one way to do it. So this is the way you do it if you don't want to change the numbers on the integral. See, the numbers on the integral right now are negative 1 and 2. If you want to keep them negative 1 and 2, then this is how you go. X world, u world, back to x world, then plug in those numbers. And then the second way of doing it, which we'll do after, is you're going to go from x world to u world. You're never going to go back to x world, but you're going to change these numbers. These numbers will change to other numbers. Okay, anyway, so let's do it the first way. X world to u world, back to x world, and then plug in the numbers, the negative 1 and the 2. All right, so we're going to rewrite our integral, and we want only u's in it. This becomes integral e to the u, okay, because my u is 4x minus 9, so we're changing the, sorry, it's so u is 4 minus 9x, so we're changing the 4 minus 9x to u. I'm going to change the dx to what it is over here, so it's du over negative 9. So the great news is my integral now only has u's in it. But you got to be careful. You don't want to just write these numbers on the integral sign because it's going to be confusing. People are going to wonder, do you plug in those numbers for u or for x or what? So I like to remind you that those are x numbers. So I'm going to write x equal negative 1 and x equal 2. So you don't plug in those numbers unless you're plugging in for an x. Okay, so let's just clean it up a little before we do the integral. So I'm just going to write negative 1 over 9 e to the u du. Okay, so we went to u world. Now we're going to do the integral. You go to u world, get a simple integral, do the integral. Okay, so now we do the integral. To do the integral, the number in the front you copy down, negative 1 over 9. And then you integrate e to the u, which is the easiest integral in the world to do. It's just e to the u. And then you're going to plug in the numbers, but we're not going to plug them in yet. But I'm just going to write x equal 2 and x equal negative 1 here. Okay, once you do the integral, you don't write the integral symbol anymore, but you write this vertical line and you're going to plug in those numbers. But don't plug them in yet. We need to go back to x world first because those are x numbers. So now in the next step, you're going to change u back to what it's equal to over here. So change this u over here to 4 minus 9x so that my answer has only x's in it. So I have negative 1 over 9 e to the 4 minus 9x And then now I don't have to write the x anymore because those are x numbers. You can write x equals still if you want, but you don't need to write it. And now you go ahead and plug them in. When you plug them in, you plug in the top one first. So you're going to get negative 1 over 9 times e to the 4 minus 9 times 2. Okay, that's what you get when you plug in 2. Then minus, and then you got to plug in negative 1. You get negative 1 over 9 e to the 4 minus 9 times negative 1. Okay, and then you simplify that. There's not much simplifying you can do. You should figure out what the powers are that are on the e there. This is 4 minus 18, so that's negative 14 right there. And this is 4 plus 9, that's a 13. And then we're going to get these two negatives to cancel. We're going to get a plus. Because that's a plus, I think I'm going to write the second term first. So the final answer is 1/9 e to the 13. I wrote this last term first. Okay, so this whole thing I wrote first. Just because it's positive. Usually I like to write the positive term first. And then it's minus 1 over 9 e to the negative 14. And that is the end of the story there. If you want, you can factor out the 1 over 9, I suppose. You can write that e to the negative 14 is 1 over e to the 14 if you want, but whatever, that's pretty much it. All right, so that's solution 1. Okay, let's go ahead and do the problem again, and we'll call it solution 2. So let me erase all this now. The u stuff and the du and everything, that's all the same. So it's just the way you do the integral is going to be different. So the way we're going to do it now is we're going to change the numbers. And you'll see it's going to be a little bit shorter this way, the second way. Just give me a second to erase here. So the second way of doing it is probably the more common way of doing it, so you definitely want to know how to do it. It's going to be called solution 2. Okay, solution 2. So again, the way we're going to do it here is we're in x world, we're going to go to u world, and then we're going to stay there. And then we're going to change the numbers, because the numbers are x numbers, and then we'll plug them in for the u, and that's the end of the story there. Okay. So again, you'd have to write down what u is, what du is. We already did that. Solve for dx. Then you want to rewrite your integral with only u's in it. So at this step here, this is e to the u, which we've already done. This is du over negative 9, which we've already done. But now you change the numbers, okay? So we're going straight to u world, and we're staying there. Okay, I got to change the numbers. So this here right now is an x number. What you can do is you can use this, the definition of u. You're saying u is 4 minus 9x. That's the way you can change from x's to u's, or the other way around. So you can plug this negative 1 in for x into this expression here and get what u is. When you plug negative 1 in, so you can plug in negative 1 right there for the x. And when you do that, you get 13, right? Because you get 4 minus 9 times negative 1. So you get 13. So this number here is going to be 13. So x equal negative 1 changes it gets changed to u equal 13. That's u, so I don't need to write a u. Okay, then you do the same thing for the 2. So this is an x equal 2, because we have an x integral here. You're going to take the x and plug it in that number 2. You're going to plug it in for x right there and calculate it and see what the u number is. So the x number, which is 2, turns into 4 minus 9 times 2, 4 minus 18, which is negative 14. So this number changes to negative 14. That shouldn't be too much of a shock. The other way we did it, we did get a 13 and a negative 14 somewhere. So it's kind of making sense. Okay, so I want you to notice what happened to my new integral. So new integral, all u's, including the numbers, are u numbers now. And now you just do this integral. When you're done, you're going to plug in these numbers, this 13 and this negative 14 in for u. And that's it. Okay. I know we already did this integral, but let's go ahead and do it again. So cleaning it up first, 13, negative 14. And this is negative 1 over 9, e to the u du. If it makes you uncomfortable that the bottom number is positive and the top number is negative, it shouldn't. It's totally fine. But if you don't like it, you could go ahead and switch them. We've talked about what happens when you switch them. You switch them and then you put a negative in the front. That negative could cancel with the negative on the negative 1 over 9 if you wanted to do that. But I'm not going to do that here. Okay, so anyway, so now you take the antiderivative, you copy the number down. The antiderivative e to the u is e to the u. Then you put the vertical line, negative 14 and 13, and those numbers go right in for u. So that's another thing that's good about this is when you go ahead and plug in, you don't have to plug into a big mess for x. I guess we already did that, so it's, anyway. But now I just plug these numbers right in for u. So we get negative 1 over 9 e to the negative 14. When you plug in negative 14, you have to plug in the top number first. Then you get negative 1 over 9 e to the 13. And then you have to subtract those answers. And again, because this turns out to be a positive, I'm going to write that term first. So it's going to be 1 over 9 e to the 13 minus 1 over 9 e to the negative 14, which is what we had before. You don't have to write the positive term first or anything, but that's something that I do all the time, so it's not a big deal. All right, so that's how that one goes. Okay, so now we're going to talk about the other time where you could use u-substitution. Remember I said that the most common application of u-substitution is if the derivative of part of the thing you're integrating is another part. And then you want to make sure you rewrite your integral all in terms of u. So the most important thing is that you're able to turn your integral from all x's to all u's. You don't want to end up with a situation where you have an integral that has u's and x's in it and you can't get rid of all the x's. Okay, that's just not going to work. You have to get rid of all the x's somehow. There should be only u's in your new integral. So what makes this a little bit harder than what we're going to do now is we're going to decide what u is, and we're going to go ahead and plug everything in, and there's still going to be some x's left that don't cancel out or anything. And when that happens, it's not a big deal. All you have to do is you have to figure out, well, how can I get rid of those x's? How can I change them to u somehow? And that's the idea. So on the slide, it just says, make sure you're able to get rid of all the x's. That's the most important thing. Okay, so if you're not able to get rid of all the x's, you need to, somehow figure out how to get rid of all the x's, or maybe your u is wrong. So let's go ahead and look at a couple examples real quick, just to see if we can guess what u is. So go ahead and look at this for a minute, maybe pause the video and see if you can figure out what u is going to be. So if you thought we should make u everything inside the root here, well, the derivative is a number, fine. So that would be u. Okay, so if you make that u, then in your next step, your integral is going to be square root of u down here. This is not a problem, but what about the x over here? What's the story here? I need to get rid of this x. Okay, and it's not going to be a problem. We're going to be able to do it. Let me show you why. Because if you say that u equals 1 plus 2x, remember, I want my new integral to have only u's in it. So I need to get rid of this x. You can get rid of it from here. What you do is you basically can take that and solve it for x. If you take this and solve for x, you get x equal, I won't show all the steps right now, but u minus 1 over 2. And then you plug that in there, and then you'll have only u's in your integral. So that's basically what makes these problems a little more complicated. So you pick your u. In this case, the derivative is a number, so I don't need that derivative somewhere else, but we still have to get rid of this x somehow. Or in another problem, if you pick your u and the derivative is somewhere else, well, still, there might be other x's in other places, and you need to get rid of them. And how do you get rid of them? You're going to use your formula for u and get rid of them somehow. In this case, you solve it for x, and you plug it in, and then you can have only u's. So that's the idea. So yeah, for this one, you do make u equal 1 plus 2x. Okay, let's try the next one. See if you can guess what u is going to be here. Again, you should probably pause the video for a couple seconds to think about it. Okay, so now I'm going to tell you what the u is going to be. So u is going to be whatever's inside this root here, the entire inside of the root here. If you make u equal to x squared plus 1, the derivative of it is 2x. Remember, I don't care about the number, but the derivative is x. I need an x to be somewhere else. Okay, well, I have an x cubed somewhere else. I don't want an x cubed, I want an x. Okay, I would like a 2x, of course, but if you don't have a 2x, at least I need the x part. So we do have an x. X cubed is the same thing as x squared times x. So we do have the x there. So okay, if you make this u, the derivative is essentially this, so that's going to cancel. But what about this guy right here? We need to get rid of that too. Remember, this is u. The derivative is this, so those two things will cancel. But what about this guy? How do we get rid of this guy? The answer is, look at your formula for u, and you could solve it for x squared. You can just take this and go, okay, x squared is u minus 1. So instead of this x squared here, you just put u minus 1 there. And when you do that, now your integral will have only u's in it. So that's the idea. Ultimate goal, you want only u's in your new integral, and of course you want to be able to do your new integral. Okay, so u is going to be everything that's under the root there. Everything that's inside the root. Okay, so let's do these two examples. Okay, so we already talked about what we're going to make u here. So let's go ahead and write that down. So we're going to let u equal 1 plus 2x. In this case, the derivative of u is just a number. So we don't need the derivative to be somewhere else, since it's just a number. So du is 2 dx. You go and solve this for dx, and you get dx equals du over 2. Okay, so now we're going to rewrite our integral. So our integral becomes, remember, this new integral now, I want only u's in it. It's an indefinite integral, so there's only one way to do it, and I don't have to worry about any numbers or anything. But okay, so I know that below the fraction line, it's square root of u, because we called 1 plus 2x u. The dx, we're going to change to du over 2. So I've taken care of this, and I've taken care of this. Now I got to figure out what to put on top. Okay, I can't put x because I don't want an x there. I want only u's in it. And this is where you're going to take this thing here and solve it for x. So I'm going to go over here. So we have u equals 1 plus 2x. You can go ahead and minus 1 both sides. And you get u minus 1 equals 2x. And then you can divide both sides by 2. And you get x equals u minus 1 over 2. It's a little bit ugly, but the point is I can change the x now to something by using my definition of u here. So you change the x to u minus 1 over 2, and we get u minus 1 over 2. Is this a simpler integral? Who knows? But at least it has only u's in it. So make sure you look at that closely and you see that we were able to get only u's in our integral. Okay, I'm going to need to erase, of course. So make sure you understood this side work here. Okay, you go and you take your u formula, you solve it for x, and then you go ahead and plug it in so that we can get rid of this x here. Okay, let's do some erasing. Okay, so it's unfortunate I have to erase this u, solving this u for x business, but don't have enough room, so we got to get rid of it. All right, so again, now I have only u's in my integral. Now we're going to rewrite it. I'm going to take this 2 here and move it to the side. Take this 2 also and move it to the side. They're going to be, it's going to turn into a 4 in the front, so it's going to be 1/4 basically. Because they're both in denominators. Okay, so the 4 is going to be in the denominator when I write it out in the front. So this becomes the integral of 1/4. And then we have u minus 1 over, maybe make it easier, I'll put u to the 1/2 here, du. Okay, now what I'm going to do is I'm going to put this u to the 1/2 underneath each of the terms on top. Remember, I'm trying to get an integral that's easy to do here. Okay, so we get integral of 1/4, and then this is going to be u over u to the 1/2 minus 1 over u to the 1/2 du. We need to put parentheses here. Okay. So then, now you can simplify this. The second term, you can just write u to the negative 1/2. The first term, u over u to the 1/2, you basically have to subtract the powers. Think of it as u to the power 1 over u to the power 1/2. Whenever you're dividing things like that, you subtract the powers. You got to do 1 minus 1/2, which is positive 1/2. So it's going to be u to the positive 1/2. Okay, now it's ready to go. We can integrate now because it's a difference. When it's a difference, you just integrate separately. And when there's a number in the front, you copy it down. So to do this integral now, you copy the 1/4 down, and then you do the antiderivative of the rest. This is going to be u to the 3/2 all over 3/2 minus, you have to add 1 to negative 1/2, gives you positive 1/2. So u to the positive 1/2 over positive 1/2. Don't write the integral symbol down anymore. Don't write the du anymore, but you do have to write a plus c. All right, let me clean it up a little bit. I think what I'll do is I'll flip the fractions and I'll distribute the 1/4. So if you flip this one, you get 2/3, and I got to do 2/3 times a fourth. 2/3 times a fourth is 1/6. And then when you flip this one, you get a 2. And I'm going to do 2 times 1/4 because I'm distributing the 1/4. So you get 1/2. So you get minus 1/2 u to the 1/2 plus c. Okay, and that's basically the answer, except my answer has to have x's in it. So in this last step here, we're going to change all the u's in our answer to 1 plus 2x. Okay, u is equal to 1 plus 2x, so you just change the u's to 1 plus 2x, and you get x's in your answer. So we have 1/6, and then instead of u, I'm writing 1 plus 2x to the 3/2 minus 1/2, and again, instead of u, 1 plus 2x to the 1/2, and then plus c. And that is the answer to this one. All right, let's go try another one. Okay, so this one is a definite integral instead of an indefinite integral. It has numbers on the integral sign, so whenever that happens, remember there's 2 ways of doing it. I will do them both ways. So let's call this solution 1. What we're going to do is I'm going to write down what we think the u is, and then figure out what du is, and then go from there. So we're going to let u equal x squared plus 1. You need to be thinking like this. If you make u equal x squared plus 1, the derivative is an x. I know it's 2x. Again, I'm ignoring the number. The derivative is x, which gives us one of these x's, but we need to get rid of the other 2 somehow. Okay, one of the x's will cancel when we plug in the dx part, but we have to get rid of the other ones. So du is 2x dx, and then you solve this for dx, and you get du over 2x. All right. Okay, so we're going to rewrite this integral now. And again, this solution 1 way of doing it, we're going to go from x world to u world, then back to x world, and then we're going to plug in the numbers. So that's the way I'll do it first. So I'm going to write x equals 0 and x equal 1 here because we're going to change things to u. And okay, so I'm going to leave the x cubed alone for a minute. The square root part is going to be square root of u because x squared plus 1 is what we called u. So we're changing the x squared plus 1 to u. Instead of dx, you're going to have du over 2x. So what I'm going to do is I'm going to leave the x cubed in here for a moment. Remember, I don't want x's and u's in there, but let's leave it for a moment. And then you see what happens. This x down here cancels one of these x's, but there's still going to be 2 x's left. So in my next integral, we're going to have integral from 0 to 1. Again, x equals 0 to x equal 1. This is going to be x squared, then square root of u, and du over 2. So now everything's great except I don't want this x squared there. So we have to get rid of the x squared. Okay, so when you do the du part will cancel some x, some of the x's, but if it doesn't cancel everything, we have to get rid of the rest of the x's. That's it. In the end, we need only u's in our integral. And so now to get rid of the x squared, we're going to use this thing. The idea is you take your u equal x squared plus 1, and you solve it for x squared, because I need to get rid of the x squared. So you just minus 1 on both sides, and you get u minus 1 equals x squared. Now some people like to take the square root of this. You might think, why don't we take the square root and solve for x? Yeah, you can do that, but I try my best not to take the square roots of things unless I have to, because then there's a plus or minus, and then I have to worry about that kind of stuff. But I don't need x, I need x squared. Okay, so because there's an x squared here, I just figure out what x squared is. And so instead of x squared, I'm going to put u minus 1. Okay, so I will have to erase now. But again, the idea is this circle thing is going to change to u minus 1. Maybe I can, let me just put the answer over here. So we found out that x squared is equal to u minus 1. Okay, so let's get rid of this. And now we get the integral from x equals 0 to x equal 1. Okay, so instead of x squared, it's u minus 1. It's going to have to go in parentheses. And then instead of u square root of u, I'm going to go ahead and write u to the 1/2. And then du over 2. Okay, this is a very important point in the problem. Okay, so we got all u's in our integral. So that's great. Now what I'm going to do is I'm going to go ahead and multiply out the u minus 1 times u to the 1/2. And then the 2 underneath the du, I'm going to just move it to the front. So it's going to be integral from 0 to 1, 1/2. And then when you multiply the u minus 1 and the u to the 1/2, when you do u times u to the 1/2, you're supposed to add the powers. U has a power of 1 on it, so it's u to the 1 times u to the 1/2. You add those powers, you get 3/2. So u to the 3/2 minus, and then 1 times u to the 1/2 is just u to the 1/2 du. And now we're ready to integrate it. So when you do the integral, you copy down the 1/2 and you integrate the rest. To integrate u to the 3/2, you're going to have to add 1 to the power. It's going to be u to the 5/2 over 5/2 minus, and then u to the 1/2 when you integrate it, it's u to the 3/2 over 3/2. Don't need a plus c here because we have numbers, but now I have to put this vertical line, x equals 0 and x equal 1. Now, of course, I'm out of room, so I'm going to erase some stuff, but the rest of it's not such a big deal. So go ahead and make sure you look at this part, make sure everything here is clear. The rest should be easy. And as you're looking, I will go ahead and start erasing. So because we decided to go from u world to x world, and then, I'm sorry, from x world to u world and then back to x world, I need to now take this expression here and change it from u's to x's. So again, the way we're going to go from u's to x's is we're going to use what we called u is x squared minus 1. So I'm going to change all the u's to x squared minus 1. So all the u's change to x squared minus 1, and I'm going to also flip these fractions and distribute the 1/2 here. So we get, if you flip the 5/2, you're going to get 2/5, and then 2/5 times 1/2 is 1/5, so we get 1/5. And instead of u to the 5/2, I'm going to put x squared plus 1 instead of the u, so x squared plus 1 to the 5/2. Again, from here, changing the u to x squared plus 1. Minus, now if you flip the 3/2, you're going to get 2/3. So if you flip this, you get 2/3. If you multiply 2/3 times 1/2, you get 1/3. So it's going to be 1/3. And then instead of u to the 3/2 again, we're going to change the u to x squared plus 1, so we get x squared plus 1 to the 3/2. And now we're plugging in 1 and 0, and notice I'm not putting x equals anymore because I'm going to be plugging in for the x's. When everything is in terms of x's, we don't have that confusion anymore. All right. So now let's go ahead and just plug them in. You plug in the top one first. Okay, so it's going to be 1/5. And then we have 1 squared plus 1 to the 5/2 minus 1/3. 1 squared plus 1 to the 3/2. Those numbers are not so nice, so we'll just have to leave it a little bit ugly. When you plug in 0, you get 1/5. 0 squared plus 1 to the 5/2 minus 1/3. 0 squared plus 1 to the 3/2. Okay, so this is 1/5 times 2 to the 5/2 minus 1/3 times 2 to the 3/2. That's that one there. And then this one here is just 1/5 because the number inside the parentheses is 1. 1 to the power of anything is 1, so you just get 1/5 times 1 minus 1/3 times 1 again because the parentheses is 1, 1 to the power of 3/2 is 1. So you get that. And there's not really much more to do. You can just go ahead and distribute the minus if you want. You can combine these fractions into one fraction. If you subtract 1/5 minus 1/3, you're going to get negative 2 over 15. So this answer here is negative 2 over 15. If I did that right, 3 minus 5, yeah, negative 2 over 15. And then with this negative, it'll become positive. So in the last step here, I'm just going to write, okay, 1/5 times 2 to the 5 halves minus 1/3 times 2 to the 3 halves, and then plus 2 over 15. And that is the answer to that one. Using this solution 1, where we go from x's to u's and back to x's. That's how that goes. Okay, let's go ahead and do the problem again using solution 2. So remember, for solution 2, the way it's going to work is we're going to go from x world to u world, and we're never going to go back to x's. So instead, we're going to go from x world to u world. We're going to change the numbers and stay in u world the whole time. And the first things you're supposed to do is you're supposed to write down what u is, find du, solve for dx. So we did all that already, so I'm going to just leave it up on top here. I'm not going to do it again. And then at some point, again, we're going to have to get rid of the x squared, so we have this u minus 1 here. When we solve this thing for x squared, you get u minus 1. So even though I'm not showing that work again, you do have to show that work, depending on which way you do it. And let's get started. So this becomes integral. So I'm going to leave the x cubed in there for the moment, then the square root of u, because remember, x squared plus 1 is u. Instead of dx, you're going to put du over 2x. Remember, I want my new integral to have only x's in it. Okay, I'm sorry, I want my new integral to have only u's in it. Right now it has both. So remember again, this x cubed and this x, there's some simplifying you could do, and you're gonna cancel an x and you're gonna get an x squared. So just because I don't know yet what's the story with the numbers, I'm gonna put a 0 and a 1 for the moment. And so we get x squared square to u du over 2. Okay, so now you just have to get rid of the x squared, make sure the integral has only x's in it. And in general, for problems like this, your job is, if there's any x's left over, get rid of it somehow, and you're going to be thinking this formula here, or your formula for u, to figure out how to get rid of the x's. If it's impossible to get rid of the x's with your formula for u, then of course you're going to need you have to figure out something else for u. Okay, so we get you may be wondering, by the way, why I haven't changed the numbers to u numbers. You can change them now if you want, but the thing is, in this step here and this step here, I have x's and u's in there. So what numbers am I going to put on the integral? Whatever numbers you put, you might get confused. Are they x numbers or u numbers? So whatever you do in the intermediate steps where you don't have all u's in your integral yet, I like to put the letter there just to remind me, oh, those are x numbers. For example, you might change them to u's, and then you might forget you changed them and change them again or something. If you do change them to u right away, I would suggest writing u equals whatever the numbers are, just to make sure you remind yourself that you changed them to u's. But in this step here, my integral is going to have all u's in it, because the x squared, we're going to change it to u minus 1. Okay, square to u du over 2. So now let me go ahead and change the numbers, and then they're all going to be u numbers. And I don't have to write u equals anymore, because everything is in terms of u. So now to get the u numbers, what you're going to do, you're going to take your x numbers. So we have x equals 0 here. You're going to plug it in here for x and get what u is. When you plug 0 in for x, you get 0 squared plus 1. You get u equals 0 squared plus 1, which is 1. So this number changes to 1. Then you can do the same thing with the other number. So you're going to plug in 1 in for that x there. And you get u equals 1 squared plus 1, which is 2. So the numbers change, that number changes to 2. So it went from integral 0 to 1, where 0 and 1 were x numbers, to now integral from 1 to 2, where 1 and 2 are u numbers. Okay, then we can go from here. Just to save a little bit of writing, let me change this square to u to the 1/2. And then we'll go from here. So now this is the integral from 1 to 2. I'm going to write the half in the front. When you distribute the u to the 1/2, you get u to the 3/2 minus u to the 1/2, like we got before, du. And then now you integrate. So you have half Notice I'm not writing the integral sign anymore now that I'm doing the antiderivative. Let's put the parentheses though. You have to add 1 to the power. It's going to be 5/2 over 5/2 minus u. This is going to be 3/2 over 3/2. Then you got to plug in the 2 and the 1. And as I did before, I'm going to flip each of these fractions and then distribute the 1/2. So when you flip the 5 over 2, you get 2 over 5. Times 1/2, you get 1 over 5. So this is 1 over 5 u to the 5/2. Minus, when you flip the other one, 2/3, it's going to be 2/3 times 1/2, it's going to be 1/3 u to the 3/2. Then you plug in the 2 and the 1. So it's very similar to the other way we did it. I mean, the integration part is similar. It's just how do you deal with the numbers? Do you change them, or do you change the u's back to x's? So this way of doing it, we're going to not go back to x's, but then our numbers just change from, instead of 0 to 1, it becomes 1 to 2. Okay, I'm out of room, so let's do some erasing. Okay, so now we're going to plug in the 2 first, and then we'll plug in the 1. So you get 1/5. I think I made an accidental mark over here. This was 5/2 here. Yeah. Okay, so it's going to be times 2 to the 5/2 minus 1/3 times 2 to the 3/2. That's what you get when you plug in 2. Then you got to plug in 1. You get 1/5 times 1 to the 5/2 minus 1/3 times 1 to the 3/2. Okay, and then remember that 1 to any power is 1. So this is just 1. This is just 1 here. So you just get 1 minus 1/3 there, which we said already was negative 2 over 15. With the minus here, it's going to turn into positive 2 over 15. So then we can write down our final answer. I'm going to write it slightly differently this time. It's going to be 2 to the 5/2 over 5. You can leave the 1/5 in the front like we did last time, but just another way to write it. Minus 2 to the 3/2 over 3 plus 2 over 15. And that is the end of the story on that one. Okay, guys, so the video is done. Please practice these like crazy. Get good at them. They're not that hard, but you want to practice them. And it's kind of fun, too. Can you figure out what the u is? Can you figure out how to get rid of all the x's? So anyway, do that. Work real hard as usual. Study hard, and I will see you next class.